We're presenting this paper at KDD to share some of the lessons we've learned designing the TensorFlow's APIs. We want to make machine learning as easy as possible, and that's all of machine learning, including deep learning, including distributed learning, including learning on huge datasets. The biggest challenge in machine learning is that it's such a quickly evolving field. If you're not careful, APIs and frameworks can become outdated very quickly. New developments can make established methods obsolete basically overnight. Flexibility is therefore our primary concern. APIs must allow custom behavior and anticipate developments and research results that haven't even happened yet. TensorFlow's main strengths are that it's very flexible and that it scales to distributed settings. We want to present an API that preserves this flexibility while making the most common usage patterns as simple as possible. Distributed machine learning gets very complex very quickly, and we believe that we have created a very simple way to get started and then scale up to any problem size or model complexity. Designing APIs means that you're making a series of design decisions, and those represent fundamental trade-offs. We have created tooling that implements best practices. This means that following best practices is very easy, while on the other hand, if you want to do something very unusual, you won't get as much help. And that's why we have designed the APIs in layers. Generally, the highest level API will get you there fastest, but if you need something specialized, you can escape to the layer below or below. The challenge for us was to make sure that you can implement some custom behavior in one part of your code, say the input processing pipeline, while reusing all of the library implementations for all the other parts of the code. Everything described in the paper is now part of the regular TensorFlow API. You can look at the estimators and feature column packages for the interfaces that we describe in the paper. They are available as of TensorFlow 1.2. If you're interested in learning more, please do read our paper. If you're new to machine learning, you can check out a talk about effective TensorFlow for non-experts that I gave at Google I/O.